We're in Larchmont, New York, and we're going to be replacing a system that was put in to waterproof a basement by another company. There's always weird glitches and things on how they install it compared to how we do it. I hope you enjoy the video. It's going to be quite interesting as we go through the process of what we uncover. We have an old stone foundation where you have stones piled up and then they mortar in from the outside and the inside. Yeah, to get into all the details of it, when you do that, oftentimes the center of the wall is hollow, and then when water absorbs in, it fills up into the center of a stone foundation wall and then goes down, and then that's how it gets into the basement. What this system is a gutter system right up against the wall, the stone wall, and is within the depth of the floor. The last thing you want to do is have your drainage anywhere near the very bottom of the wall. There's a reason for that. Stone foundations don't have traditional footings like a traditional three-piece foundation, whether it's block or poured, where you have a footing and then the wall sits on the footing, and then the floor is poured so it sits on the inside of the footing up against the wall and it holds the walls out. That's not the case with an old stone foundation. You have the stone foundation, it's built right on the ground, and the way that they try to establish a footing is that they'll put the larger pieces of stone on the bottom and then work their way up the wall, you know, piece by piece, and then mortaring from the outside and then mortaring from the inside. So there's no real footing. How you have to address that is entirely different than what a normal gutter system would ever be used for. It's about this much drainage, and where this is, as you'll see as we take it out, is all within the depth of the floor. If you manage water within the depth of the floor, water's got to come up against the bottom of the floor, slide across the bottom of the floor, and in this particular situation, this type of foundation, it's got to work its way around the side of the floor before any water will actually get into this particular type of drainage. For that scenario to occur where the water is actually traveling through their system, there has to be an enormous amount of pressure underneath the floor. Where does that pressure come from? Well, it starts on the outside of the walls. Stone foundation walls, they can go anywhere from this thick to this thick, usually not too much thinner than this, but then you have your backfill area out there where they had to dig up in order to gain room in order to build the walls and do the mortaring from the outside in. So that soft soil collects water, and water builds up on the outside of the wall and then is able to force its way around the stones through the mortar. And especially stone foundations, they tend to be much older types of foundations. So when the water builds up on the outside of that wall, pressure occurs and it forces water in around whatever stones are there. Now here's the thing. The mortar, when it first was there, acted like waterproofing, because in the old days, the fancier types of waterproofing on the outside of walls just didn't exist. So the old stone foundations kind of had to rely on the mortar that you see holding the foundation together here between the stones. This was put on later because water was coming through the walls. But if you look between the stones, that's what held basically the foundation together. And it also acted as the waterproofing to keep water from just flowing through these stones rapidly, or in heavier storms, you'd get a whole lot of water. But if you look here, this is just the water that's absorbed through and has turned that mortar into a very sandy type of mix. So what you need to address properly when you're dealing with a stone foundation is to make sure that you have your drainage in the right place. What we're going to be doing here is well, first of all, we're removing this whole system. It's going to go out and be just discarded, thrown into the dumpster. But then what we're going to do is we're going to make sure that we create a footing, and we're going to come out several to 10 inches away from the wall, and then we're going to start to dig down. What we're effectively doing is creating a footing, because our drainage is going to be down 10 to 12 inches, where theirs is literally within the depth of the floor. So the difference is their drainage would be here, our drainage would be here. What our drainage is able to do then is create so much volume, manage so much volume of water, that will actually be able to drop that water table that's on the outside of the walls that comes after a heavy rain. We call it a false water table. It's very real, but we call it false because it's temporary. It's only there for a couple of weeks until the water percolates down into the very dense undisturbed soil. We call that like a hard pan clay. So if you put soft stuff on the outside of your wall, water has two properties. It follows the path of least resistance. Well, you've just created that on the outside of your walls, because that soft soil, if the ground is filled with water, it's going to dump in on the outside of your walls and sit there for a couple of weeks. And depending on how wide it is, and with stone foundations, that can vary. There's regular code for the newer foundations, whether they're block or poured foundations. For every foot you go down, you have to go out a foot. Those rules really didn't apply when they were doing the old stone foundations. Kind of was before anybody was really watching. So you're never sure just how wide of an area you have on the outside of your walls. The wider it is, the more water builds up out there, the stronger the pressure. The stronger the pressure, the more it's going to force its way in around the stones and then into your basement. So you need a high volume system in order to drop that water table on the outside of the walls and try to get it down to a manageable point down here. And you need a high volume system in order to do that. The exact opposite of what we're about to tear out here. And I think you're going to find it pretty interesting. And if you are in the market to get your basement waterproofed, think about volume, think about structural integrity. And with a stone foundation, you want to think about the possibility of your waterproofing system actually undermining the soil that's holding up your stone walls. And they're very, very heavy. This foundation has a waterproofing system like I just described, but it's around the entire foundation. It's around all four walls. Now, we needed to gain access to it, so we had to take out, it was already finished, which is another thing. You get the wrong system, then you finish the basement and you realize it's the wrong system for your particular type of foundation. It's just not doing what you need done and for this space to be a viable, usable, and even livable space. That's a disaster. I mean, to have to redo this entire thing. I mean, one thing you never ever want to do twice is to waterproof your basement. These things are little caps where they cut holes into where the system goes, and you can remove it to gain access into the system. I'm putting my hand in, that's the bottom of their drainage. So their whole drainage is all you get in order to manage whatever type of waterproofing system that you have. Once you take the cap off, you now have access, and what they do is they put like a power washer in and they blow out all of whatever could grow in there. Now, one of the nemesis of these systems, of the gutter systems, is that they grow bacteria and fungus and they fill up, so they need to be maintained. The company likes to get a contract with the customers so they can come back once a year. They actually recommend to come back twice a year. To flush the systems out. It's a couple $100 each time that they come. So over time, it becomes very expensive. The reason that these things tend to fill up with all those different bacteria and mold and fungus is that there's no pitch. They put them in and it's completely level. No matter what they tell you, it sits flat on top. But we would take a level, put it on, and the level would be exactly level. There's no pitch to it whatsoever. So if water did get into it, as water percolates back out, these things have like a lip to the access point, and it holds water in it even though things dry out. And when it does it, that standing water is what causes the mold and the mildew and the fungus and this other stuff called iron ochre, which is the major plague for this thing, and that's why they need to be flushed out. If not, they fill up and then there's no drainage whatsoever. It's kind of a catch-22. If you don't do it and then you have a big storm on the way, you kind of get nervous. Geez, I'm behind on my maintenance with my waterproofing system and there's a lot of rain coming. Am I going to flood? The way we do things in American Dry Basement Systems is we put an enormous amount of drainage in. Our systems are perpetually self-cleaning, so you never have to worry about this, and you don't need to get flushed out a couple times a year at a couple $100 a pop. So you're saving a whole bunch of money with a system that's going to do 10,000 times more than what these type of systems do. The idea of any waterproofing system is that it's a continuous system, that there's continuity, that it's all attached, and it allows the flow of water from one area undisturbed, uninterrupted, all the way around to where the pumping station is. In this case, the pumping station was here, so water was working around from here all the way around through here to the pumping station, and the same thing around the other side in order to do that. And every time we tear one of these systems out, and we tear them out all the time, we run into things that truly are amazing, that actually we shake our heads at and think like, this is not what this particular customer was sold. I guarantee it. They never covered what I'm about to show you. Well, watch and see, and this is a head shaker, because if this is how they describe the system and people still bought it, I'd be more surprised at that than just about anything.
When you get to an obstacle like a sewer line like this, here's what they did. If you look here, the way they hold their pieces of drainage together is with duct tape. I mean, so you have two pieces. I can't see that be a continuous run, but that's the least of the issues that we're talking about here. When they hit this sewer line, take a look at that. They just cut through their system, made a huge hole so that they could fit this thing down into here and have it go around, and they rounded it so that it would fit around the pipe. If you look, what I want you to focus on, this was flat, but when I pulled that piece, it pulled this up. And this corner, section, it doesn't have a bottom. So if you look here, you got more duct tape going right there, and then it's just another piece that's scabbed into here. Duct tape here, but they managed to use a tiny little leftover piece in order to just match up with that bottomless corner piece that went over top. Have another hodgepodge. This is like Legos, where you have little pieces, you just keep putting them all together. Unfortunately, Legos is something you don't want to be attributed to how you waterproof your basement. We'll tear out this piece. If you look at the bottom, that's how they held it together. You got a gap here, you got a gap there, and they just bent it so that it would fit around the back. But that's not a continuous system. So this is, it's all over the place, everywhere. Anything that's not absolutely straightforward, yeah, I don't think that was really covered in the how to fix your basement presentation by the gutter system people.
We're finishing up here at Larchmont, New York, and nothing has ever made it clearer that there's definitely a wrong way to go about waterproofing your basement. We've just seen just a horrific case of the wrong system for this particular type of foundation. Do your homework. Make sure you understand what type of foundation you have. We'd love for you to call us at American Dry Basement Systems, but don't just do that. Get 2 or 3 other estimates, even 4 if you can stand it, and then compare it to how we do it. We guarantee that you're going to call us and say, hey, how quick can you get out here and fix our basement? Because there's 3 or 4 questions you want to ask, which we'll cover with you after we do our inspection and sit down and explain everything. And when you ask those to the other 2 or 3 people that are going to sit down in front of you and explain how they're going to waterproof your basement, it becomes crystal clear there's definitely a right way to go about it. That's what we pride ourselves on at American Dry Basement Systems. So if you like the video, hit the like button, subscribe, and until next time, enjoy your dry basement.